They say east unit? Hey, we'll give you a chance to ask questions on what was it? 8 or 7-12? Is that what we did on Friday? 7-12. We'll give you a chance to ask some questions on any of those. The numbers on this thing will be different than the numbers on your page. 7-12. Is that the right number? Was your first problem 31,233 grams of phosphorus pentachloride? Was that your first problem on 8-12, 7-12? Do I have the right number? I hope so. What kind of questions do we have on this? This one we tried to speed it up a little bit, give you the units, but what questions do we have? Could not enter grades over the weekend. Some reason I'm blocked on Power School now. So I could not enter your grades. So if you're like, I've turned work in, it's not posted yet. I realize that. Sorry. Do we have questions on this first problem? Is this the same as your number one? Questions on it. How about your number two? Was that the one where they were asking about the gas laws? Yes. Yes. Did you look at this? We went over this one on, well, really 2 days. We went over, do you remember when we talked about it? 8- right here. We went over this. So if you're wondering where that information is, these were the gas laws that we discussed. I think it's in the molar volume one, class note 7-9, I think. Right here. When we talked about where does 22.4 come from, did we get to go over there and show you how they got 22.4 from Pivner? Where does the 22.41 1 mole of gas takes up 22.4 liters of space? And that is only at STP, 0 Celsius in 1 atmosphere. Because if you change the pressure, what happens to the volume? If you increase the pressure on a gas, what happens to the volume? It goes down. So they have to select a pressure for standard temperature and pressure. They picked 1 atmosphere. What happens if you increase the temperature on a gas? If you increase the temperature on a gas, what happens to the volume? Goes up. Volume goes up. That's Charles' law. These are the laws. Boyle's law, increased pressure, volume goes down. Increased temperature, volume goes up. The temperature they pick for the molar volume is 0 Celsius. Did we show you where the 22.4 comes from? Because it is 1 mole. 1 mole of gas takes up 22.4. Only at 0 Celsius. Only at 0 Celsius and 1 atmosphere. If you have a different pressure and a different temperature, the volume will be different. If pressure goes up, what has to happen to volume? According to this equation, if pressure goes up and this is going to stay the same, what has to happen to volume? If this number gets bigger, what does that number have to do? Get smaller if they're going to stay equal. That's Boyle's law. Charles's law, if the temperature goes up, what has to happen to the volume? If this side goes up, what happens to this side? If pressure stays the same, what has to happen to volume? It also has to go up. That's Charles's law. Avogadro said that if we increase the number of moles of gas, N is the number of moles of gas, and we keep this constant, this constant, this constant, what has to happen to the volume? If N goes up, stays the same, stays the same, stays the same, what does V have to do? Go up. That's Avogadro's law. What happens if the temperature goes up and this stays the same, this stays the same, this stays the same? What has to happen to pressure? It will have to go up. That's the Gay-Lussac law. But when they calculate the molar volume of a gas, they have to pick what temperature and pressure to do it at. What pressure did they pick? What standard pressure? 1 atmosphere. We want to know what the volume is of a gas at 1 atmosphere of pressure. The molar volume is the mass or the volume of what? How many moles? The molar volume is the volume of how many moles? 1 mole. So I'm going to plug in 1 for N. Are you sure we didn't show you this? You guys are acting like we showed you this. You're like, we know what you're doing here. You're calculating the V. R is a constant. It is 0.0821. It's the constant that makes these sides equal. What does the temperature need to be? Yes. 0 Celsius. But we can't plug in 0 there. In the gas equations, you can't plug in 0 Celsius. That's not the scale they're able to use. Are you watching this, sir? I'm right up here. This is very important. We can't plug in 0 Celsius, which is the freezing point of water, because this side go to what? 0. Is the volume of a gas, is the volume of gas at freezing 0 Celsius, is it 0? So when the temperature in the winter gets down to 0, does all the gas in our atmosphere immediately cease to have volume and the gas molecules fall on the ground? We lose our entire atmosphere at 0 Celsius. No, that's not the scale they use. They use the Kelvin scale. To get the Kelvin scale from the Celsius scale, we merely need to add 273. 273. What is, are you watching me, sir? What are you possibly typing right now? What? So, if we have 0 Celsius, what do we plug in? We merely add 273. 0 Celsius is how many Kelvin? We add 273. It's 273 Kelvin. Now, I'm leaving the units out here so that you can just look at the numbers and not be confused by the units. At what temperature does gas then cease to have a volume? What is the lowest you could get on the Kelvin scale? 0. 0 Kelvin. How many Celsius is 0 Kelvin? Remember, we add 273 to get from Celsius to Kelvin. Yes, that's correct. Minus 273 is not a temperature you want to be at. I think you might explode from the inside out. Minus 273 Celsius, 0 Kelvin is no energy. So the gas molecules would stop moving. and just fall. There would be no atmosphere. Gases would not have a volume. So let's see what the volume is at 1 atmosphere of pressure and 0 Celsius or 273. What is the volume? What would the volume be? 1 times V is V. So what's the volume? What is the volume of 1 mole of gas at 1 atmosphere of pressure and 0 Celsius or 273 Kelvin? Who tried that on their calculator? What did you get? 22.41 333 22.41 or 22.4. You see where they get it? Your answer is in the gas laws. So we look again then at your question. You said you did not understand. What was it? Number 2. Increasing the pressure on a fixed amount of gas will decrease its volume. Who says that? That's Boyle. You see where we got that? Increasing the temperature on the gas will increase the pressure. Who says that? That's the Gay-Lussac. Equal volumes at the same temperature and pressure will contain the same amount of gas. That's Avogadro. And finally, increasing the temperature will increase the volume. That's Charles. So Avogadro just says equal volumes at equal conditions contain equal gases. In other words, the volume of a gas depends on how much gas you have. The more gas you have, the greater the volume will be. What else do we have? Thank you for asking that, sir. Always excited to go over that question. How about number 9? Or your number 3, I think it is. Is that number 3 on yours? Any questions on number 3? How about your number 4? Number 4. This one you had to write inequality because you were staying within quantity count. Questions on any of these? Folks, we are now ready to move on. Now that we can do these calculations, calculating a mass of something to moles, moles to mass, moles to volume, volume moles. We can calculate moles to quantity count to moles for a particular substance. We can also go mass to quantity count to mass for a particular substance. And we can also calculate mass to volume of a gas, volume back to mass of a gas for a particular substance. But now it is time to begin to understand the power of chemical equations. And we can extend the use of the calculations we just used to do real chemistry called stoichiometry using balanced chemical equations. As we start into understanding what chemical equations tell you in terms of chemical reactions, what we need to do first is explore the types of chemical reactions. And that's what we're going to do today. Today, we move into Unit 8. If you do not have all of your Unit 7 assignments in, you have till Wednesday. You might want to make a note of this. Unit 7, late work, must be turned in by Wednesday, 3 p.m. Because today we move into Unit 8. Types of reactions, chemical equations. We start off today working on 8.1 and 8.2. In 8.1, you're going to learn about the types of reactions. In 8.2, you're going to see actual demonstrations of those types of reactions. Both are due tomorrow morning. You have the rest of this period to get started. Understand 8-1 is your notes introducing the type of reactions. So actually watch the videos and fill out the note sheets that accompany it. Good luck.